Electrical inspectors sometimes reject installations due to improperly torqued receptacle and switch mounting screws. The National Electrical Code, or NEC, does not specify particular torque requirements for receptacle or switch screws. However, Underwriters Laboratories, or ALL, an independent safety testing organization, recommends specific torque values. For receptacle ground screws, a torque of 15 to 25 inch-pounds is recommended. For receptacle mounting screws, the recommendation is 10 to 15 inch-pounds. Switch screws should be torqued to 8 to 12 inch-pounds. To ensure proper tightening, use a torque wrench or a screwdriver with a torque driver. Follow the torque values recommended by UL or the manufacturer of the devices being installed. Over-tightening can damage the screws or strip the threads in the electrical box, while under-tightening can create loose connections, which leads to a lot of heat and risk of fire. Loose screws can cause arcing, overheating, and electrical fires. Over-tightened screws can strip the threads, making it difficult to replace or maintain receptacles and switches in the future. Some jurisdictions require electrical contractors to document that receptacle and switch screws have been properly torqued. This documentation may be included in the job inspection report or a separate certification. The National Electrical Contractors Association, or NECA, recommends using torque wrenches for all electrical installations. The International Association of Electrical Inspectors, or IE, also emphasizes the importance of proper torquing to ensure the safety and reliability of electrical systems. Proper torquing of receptacle and switch screws is critical for electrical safety and compliance. Failure to adhere to recommended torque values can result in job delays, fines, and potential safety hazards. When installing electrical devices, consider these points. Firstly, always de-energize the circuit before working on any electrical component. Secondly, use properly rated tools for the job, including a torque wrench or screwdriver with adjustable torque settings. Thirdly, consult the manufacturer's instructions for specific torque recommendations for the devices being installed. Fourthly, inspect the screws and threads before installation to ensure they are clean and free of damage. Fifthly, start with a low torque setting and gradually increase it until the recommended value is reached. Sixthly, avoid over-tightening the screws, as this can damage the device or the electrical box. Seventhly, after tightening the screws, double-check that the device is securely mounted and does not move. Eighthly, document the torque values used for each device in the installation report. Ninthly, stay up to date with the latest electrical codes and standards to ensure compliance. Tenthly, if unsure about any aspect of the installation, consult with a qualified electrician. Proper torquing is not just about meeting code requirements, it is about ensuring the long-term reliability and safety of the electrical system. Loose connections can lead to increased resistance, which in turn generates heat. This heat can damage the insulation on wires, melt plastic components, and even ignite nearby combustible materials. Properly torqued connections provide a tight, secure bond that minimizes resistance and reduces the risk of overheating. In addition to fire hazards, loose connections can also cause electrical arcing. Arcing occurs when electricity jumps across a gap between two conductors. This can create a shower of sparks and intense heat, which can quickly ignite flammable materials. Properly torqued connections eliminate these gaps, preventing arcing and reducing the risk of fire. Furthermore, loose connections can lead to voltage drops, which can affect the performance of electrical equipment. Voltage drops occur when the voltage at the device is lower than the voltage at the source. This can cause lights to dim, motors to run slowly, and other electrical equipment to malfunction. Properly torqued connections ensure that the voltage remains consistent throughout the circuit, preventing voltage drops and ensuring optimal performance. The NEC addresses the importance of proper connections in several sections, although it may not specifically call out torque values for receptacle and switch screws. For example, NEC section 110.3 B requires that equipment be installed and used in accordance with the manufacturer's instructions. This includes following any torque specifications provided by the manufacturer. NEC section 110.14 requires that conductors be properly terminated to ensure a good electrical connection. This includes tightening screws and terminals to the proper torque. NEC Section 314.25 requires that boxes and fittings be securely mounted. This includes tightening the mounting screws to the proper torque. While the NEC may not explicitly state torque values for receptacle and switch screws, it does emphasize the importance of proper connections and secure mounting. By following UL recommendations and industry best practices, electricians can ensure that their installations meet these requirements and provide a safe, reliable electrical system. In addition to UL and NECA, other organizations also provide guidance on proper torquing techniques. The Institute of Electrical and Electronics Engineers, or IEE, publishes standards that cover a wide range of electrical topics, including wiring and grounding. These standards may include recommendations for torque values and tightening procedures. The National Fire Protection Association, or NFPA, publishes the NEC, which is the most widely adopted electrical code in the United States. The NFPA also offers training and certification programs for electricians and other electrical professionals. These programs emphasize the importance of proper torquing and other safe work practices. Many manufacturers of electrical equipment also provide detailed instructions on proper torquing techniques. These instructions may include specific torque values for different types of screws and terminals. It is important to consult these instructions before installing any electrical equipment. There are several different types of torque wrenches and screwdrivers available. Some torque wrenches are designed for heavy-duty applications, while others are designed for more delicate work. Torque screwdrivers are typically used for tightening small screws and terminals. It is important to choose the right tool for the job. When using a torque wrench or screwdriver, it is important to calibrate it regularly to ensure accuracy. Calibration involves checking the tool against a known standard and adjusting it if necessary. Most torque wrenches and screwdrivers have a calibration adjustment screw. It is also important to use the correct size and type of bit or socket for the screw or terminal being tightened. Using the wrong size or type of bit can damage the screw or terminal, or it can lead to inaccurate torque readings. When tightening screws and terminals, it is important to apply a steady, even pressure. Avoid jerking or over-tightening the screws. Once the recommended torque value is reached, stop tightening. It is also important to avoid loosening the screws after they have been tightened. Loosening the screws can weaken the connection and increase the risk of overheating. If a screw needs to be loosened, it should be retightened to the recommended torque value. In some cases, it may be necessary to use a thread locking compound to prevent screws from loosening. Thread locking compounds are available in different strengths and formulations. It is important to choose the right compound for the application. When working with electrical equipment, it is important to wear appropriate personal protective equipment, or PPE. This includes safety glasses, gloves, and insulated tools. Safety glasses protect the eyes from flying debris. Gloves protect the hands from electrical shock and burns. Insulated tools protect the user from electrical shock. Before starting any electrical work, it is important to inspect the work area for hazards. This includes looking for exposed wires, damaged equipment, and other potential dangers. If any hazards are found, they should be corrected before starting work. It is also important to follow lockout-tagout procedures to prevent accidental energization of the circuit. Lockout-tagout procedures involve disconnecting the power source and placing a lock and tag on the disconnect switch. The lock and tag indicate that the circuit is being worked on and should not be energized. When working with electricity, it is important to be aware of the potential hazards and to take appropriate precautions. By following safe work practices, electricians can minimize the risk of accidents and injuries. In summary, proper torquing of receptacle and switch screws is essential for electrical safety and compliance. While the NEC does not specify torque values, UL recommends specific values for different types of screws. Electricians should use a torque wrench or screwdriver to ensure that screws are tightened to the proper torque. Improper torquing can lead to loose connections, overheating, arcing, and electrical fires. It is also important to document the torque values used for each device in the installation report. By following these guidelines, electricians can ensure that their installations are safe, reliable, and compliant with electrical codes and standards. Remember, the specific torque values provided are general recommendations. Always refer to the manufacturer's instructions for the exact torque requirements for the specific devices you are installing. These instructions may be printed on the device itself, included in the packaging, or available on the manufacturer's website. Deviating from the manufacturer's recommendations can compromise the integrity of the connection and void any warranties. Also, keep in mind that different types of screws and terminals may require different torque values. For example, screws made of different materials, such as steel or brass, may have different torque requirements. Similarly, different types of terminals, such as screw terminals, push-in terminals, and wire connectors, may require different torque values. Be sure to use the correct torque value for the specific type of screw or terminal you are working with. Furthermore, consider the environment in which the electrical devices are being installed. In corrosive environments, such as those found in coastal areas or industrial settings, it may be necessary to use screws and terminals made of corrosion-resistant materials. These materials may require different torque values than standard materials. In high-vibration environments, it may be necessary to use thread-locking compounds to prevent screws from loosening. Thread-locking compounds can also affect the torque required to properly tighten the screws. Also, remember to inspect the screws and terminals for any signs of damage before installation. Damaged screws or terminals should be replaced to ensure a secure connection. Using damaged components can compromise the integrity of the connection and increase the risk of failure. When using a torque wrench or screwdriver, be sure to follow the manufacturer's instructions for its use and calibration. Improperly calibrated tools can provide inaccurate torque readings, which can lead to under-tightening or over-tightening of the screws. It is also important to use the correct units of measurement when setting the torque value on the tool. Torque is typically measured in inch-pounds or foot-pounds. Be sure to select the correct units of measurement to avoid errors. Also, consider the accessibility of the screws when selecting a torque wrench or screwdriver. In tight spaces, it may be necessary to use a specialized tool with a low profile or a flexible head. Using the wrong tool can make it difficult to reach the screws and apply the proper torque. And finally, remember that proper torquing is just one aspect of a safe and reliable electrical installation. It is also important to follow all other applicable codes, standards, and best practices to ensure the safety of people and property. This includes using properly rated conductors, grounding equipment correctly, and protecting circuits with appropriate overcurrent protection devices. A comprehensive approach to electrical safety is essential to prevent accidents and ensure the long-term reliability of the electrical system. It's not just about tightening screws, it's about a commitment to safety and quality workmanship.